Hello everyone, welcome. Today I'm going to take you through an amazing ride. You are going to go supersonic. You are going to fly really high. बहुत मस्त उड़ने वाले हो आप लोग. इस उड़ान के लिए तैयार हो जाओ. And इतना मस्त उड़ोगे कि फटाफट you will remember all the formulas. So are you guys ready? Are you guys ready to take off? Welcome, this is Shreyas here, your master teacher for physics at Vedantu, going live from the studios at Bangalore. Welcome. I am first of all so thankful to Dr. Vani ma'am for inviting me here. I mean, more than that, it is a moment of pride for me. I'm genuinely so happy that I will be teaching somebody who is going to be a doctor, who is going to do some miracles, who is going to save so many lives. I am so glad. I'm so glad to be here. I just cannot express. I'm really thankful to Dr. Vani ma'am for calling me here, and I wanted to really inspire you. I really wanted to, learn these amazing formulas. ये formulas physics के जो बहुत ही मुश्किल होते हैं, मैं चाहता हूं कि आप ये सब आसानी से रटो and उसके साथ साथ relationships भी देखो, so that you get really amazing marks in the forthcoming NEET examination. Hello everyone. Oh, somebody is there by my name. Hi Shalini, Annie, Rajeshri, Harish, Ashwin, Preeti, Dheeraj, Avantika. Wow, look at that amazing crowd which has gathered today. मुझे शायद नाम भी पढ़ने नहीं हो रहे हैं, इतना ज़्यादा प्यार, इतना ज़्यादा मतलब lit है आज माहौल, पूरा मतलब माहौल बन गया है आज. Look at that, amazing. I just see so many hearts. So guys, a quick introduction. I have been teaching for quite some time now, and some of you might have already seen me on some other channel, or maybe in some master classes or some other social media videos or something like that. So I train kids. I love training kids. I love inspiring them and motivating them to learn physics, to crack the examination, no matter which examination it is, be it NTAC, be it JEE, be it NEET, फर्क नहीं पड़ता यार. सब एग्जाम्स क्रैक करने के लिए एक ही चीज बहुत जरूरी है, एंड दैट इज स्ट्रॉन्ग डिटर्मिनेशन एंड फेथ. यस, यू शुड बी डिटरमाइंड एंड यू शुड हैव फेथ. नो मैटर विच टीचर इट इज, नो मैटर विच चैनल यू स्टडी, यू शुड ऑलवेज हैव दैट डिटर्मिनेशन इन योरसेल्फ एंड द फेथ इन योर टीचर. दैट्स इट, दैट्स ऑल यू नीड. तो आज के लिए तैयार हो जाओ गाइज. आज बहुत ही मजा आने वाला है. ओके, so get that Josh high, keep that Josh high, let the chat box be flooded, because guys, आज की फीस जो है, the fees that I have charged, yes, the fees that I have charged for coming to this channel is very high. Yes, remember that the fees is very high, and it's very difficult to pay those fees. The fees is your likes, your comments, your messages on the chat box. It's very difficult to pay those fees. So guys, do not stop that likes, do not stop those subscriptions, do not stop those chats. Keep those likes flowing, keep those subscriptions down there, keep the chat box flooded. Very good. Ready to fly? Let's go. So how many of you face this difficulty? यार ये फिजिक्स का फॉर्मूला समझ में नहीं आता यार, इसको कैसे याद रखूं? अच्छा, ये याद रखता हूं तो वो भूल जाता हूं, ये याद रखता हूं तो वो भूल जाता हूं. करे तो क्या करे? समटाइम्स दे आर सो कंफ्यूजिंग. ये ऊपर, ये कभी नीचे, यार समझ में नहीं आता. हैव यू फेस दैट? होता है कि नहीं आप लोग के साथ? कोई बात नहीं, अपन है, मैं हूं ना. ऑलराइट, डोंट वरी, मैं हूं ना. सो सबसे पहले ऑल इज वेल बोलो, ऑल इज वेल बोलो, दिल पे हाथ रख के. एवरीथिंग विल बी फाइन, एवरीथिंग विल बी फाइन. एंड लेट्स सी द फर्स्ट टिप फॉर टुडे. यस, ऑल इज वेल, वेरी गुड, ऑल इज वेल. पहला ट्रिक बहुत ही मिसलीडिंग होता है. सबको पता होता है बट पता नहीं होता कि कैसे करना है और क्यों करना है. एंड दैट्स व्हाट आई एम गोइंग टू टेल यू. व्हाई मेकिंग नोट्स इज सो इंपॉर्टेंट फॉर लर्निंग फॉर्मूलाज, डेफिनेशंस, कॉन्सेप्ट्स इन फिजिक्स. तो ये सबसे पहला मेरा आज का पॉइंटर है. सो हाउ टू मेक नोट्स. So before we go to the next trick, this is the first major trick, how to make notes. सबसे पहले बात, ध्यान से सुनना सब लोग. I hope you are making notes on how to make notes, है ना, ये मत भूल जाना. Make notes on how to make notes. अच्छा, सबसे पहला पॉइंटर गाइस, योर नोटबुक फॉर फिजिक्स की बात कर रहा हूं मैं, बाकी सब्जेक्ट्स की बात नहीं कर रहा हूं, बिकॉज ऑब्वियसली देयर आर अदर टीचर्स हु विल टेल यू हाउ टू मेक केमिस्ट्री, बायो और अदर नोट्स. ओके, सबसे पहला पॉइंटर, your physics notebook should be at max 300 to max बहुत ज्यादा बोले तो 400 pages only. Yes, 300 to 400 pages only, इससे ज्यादा नहीं. I would be happy if it is 300. जब मैंने मेरी जेई की तैयारी की थी and I got almost full marks in physics, yes, in the JEE advanced exam की बात कर रहा हूं मैं. Okay, my chemistry and other subjects were not that great, but my physics was really good. So that's why I enjoy teaching physics, by the way. तो मेरा जो फिजिक्स का फंडा बुक था, फॉर्मूला बुक था, उसमें 300 से 400 पेजेस ही थे, उससे ज्यादा नहीं थे ना. उसमें क्या था वही तो मैं बताने वाला हूं. ओके, व्हाट एंड ऑल वर देयर इनसाइड दैट बुक. ओके, ऑब्वियसली फॉर्मूलाज तो हर कोई बताता है. एवरी नाउ एंड देन यू सी, अच्छा फॉर्मूलाज नोटबुक में लिखो, बट ये कोई नहीं बताता कि फॉर्मूलाज के साथ कैसे और भी चीजें जुड़ी होती है. What is important that you just don't write the formulas, but you also write when to use, when not to use, yes, when not to use, and the different terms in it. जैसे मान लो कोई टाइम ऑफ फ्लाइट का फॉर्मूला है 2u sin theta by g. I have seen so many times people remember that formula. Oh, 2u sin theta by g. एग्जाम में भूल जाता है, सर u क्या था, अरे ये थीटा कहां से था. So you forget that. So it's very important you write down what each term means. It's very important. Okay, I'm coming to NCERT and other things. Yes, don't worry. I know what and all you think. Okay, अच्छा ये हो गया फॉर्मूलाज में. इसके साथ साथ always try, whenever you try to remember a formula, do not try to remember it like this, 2u sin theta by g, 2u sin theta by g. ना, ऐसा ना करो. Try to put values and try to increase and decrease them and play with that formula. Example, मान के चलो अभी क्योंकि हम टाइम ऑफ फ्लाइट की ही बात कर रहे हैं, 2u sin theta by g, ये टाइम ऑफ फ्लाइट का फॉर्मूला होता है फॉर अ प्रोजेक्टाइल. प्ले विद इट. जैसे मान के चलो g इंक्रीज होगा तो क्या होगा भाई, द प्रोजेक्टाइल विल कम हिट द अर्थ वेरी फास्ट. तो जब g बढ़ेगा तो टाइम ऑफ फ्लाइट कम होगा, इसीलिए तो g नीचे है. अब ये सोचो u ऊपर क्यों है. अच्छा, u ऊपर क्यों है, बिकॉज अगर स्पीड ज्यादा होगा, ज्यादा स्पीड से फेंकोगे तो टाइम ऑफ फ्लाइट भी ज्यादा होगा, तो इसलिए u ऊपर है. ऐसे करके याद रखो, तब कभी नहीं भूलोगे. आई होप यू आर गेटिंग माई पॉइंट. सबको समझ में आ रही है मेरी बात. एवरीबडी इज गेटिंग इट. पुट स्पेशल वैल्यूज. अच्छा, और एक और चीज भी देखना, वो 2u sin theta by g वाला जो फॉर्मूला है, दैट फॉर्मूला, इफ यू पुट थीटा एज 90 डिग्री, तो सोचो यार व्हाट इज साइन ऑफ 90. इट इज 1. तो क्या हो जाएगा, इट विल बिकम 2u by g. That means try to think, आपने प्रोजेक्टाइल को ऐसे नहीं फेंका, you have thrown it up like this, so it goes up and comes down. So what is the time of flight in that? It is just 2u by g, है ना. So remember it like this, then you will not forget. Don't remember 2u sin theta by g. Now you'll forget it. Okay, that is clear. Next, very important, NCERT and HC वर्मा. These are your, इसको प्रणाम करो सबसे पहले तो, ये दो बुक्स, these are your books which are going to help you crack the NEET examination. इसके सारे definitions, important definitions and important pointers जो भी रहेंगे, and graphs and charts and diagrams. ये सारे चीजें, yes, all these things should be there in your fundamental book, in your formula book. Yes, all these things should be there in your formula book. If it's a sonometer experiment, sonometer का diagram होना चाहिए. Yes, you should have that sonometer का diagram. If there are some graphs related to that experiment, that graph should be there. If some charts are there, some flow chart is there, okay, then that flow chart should be there. Everything should be there. अब आप बोलोगे sir, should I draw it nicely, write it neatly? No. Please understand, these notes are not for publication. You are not going to become an author making this book. Keep that in mind. That is only for you and not for your friend. You're not supposed to show this to anyone. It's only for you. So you make it your way. It need not be colorful. It need not be flowery or anything. It should be something which you understand. Right? Anyways, आप डॉक्टर्स बनने वाले तो आई एम गेसिंग आपके हैंड राइटिंग्स भी बहुत ही सुंदर होंगे. आई होप यू अंडरस्टैंड द सरकाजम. एनीवेज, सो गाइज, आप टेंशन मत लो. हैंड राइटिंग आपको समझ में आना चाहिए, बस आपको समझ में आना चाहिए. यस, दैट्स ऑल. ओके, सो कीपिंग दिस इन माइंड, व्हाट एल्स शुड बी देयर? व्हाट एल्स शुड बी देयर? मेरे फंडा बुक में और क्या था? मेरे फॉर्मूला बुक में और क्या था? ओके, lot of people ask, sir, SL Arora, sir, DC Pandey, sir, what about that? No, 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 you don't need all this. Whatever ranks that I have produced, 2-digit ranks, इन्होंने सिर्फ NCERT, HC Verma and the question bank and the previous years, that's all they did. उससे ज्यादा नहीं लगता भाई, नहीं लगता. Only these 2 books for theory and problems, and what did I say? Previous years NEET question. Yes, question bank होगा, and your coaching का question bank. If you are in Vedantu, you will get Tattva module. If you are in some other coaching, you will be having that module. बस उससे ज़्यादा ज़रूरत ही नहीं है. Understand that. Yes, very good, very good. Okay, now what else apart from this? Okay, same point continued. ध्यान से देखो, ये point कोई नहीं बताता मेरे फंडा बुक में क्या था. ध्यान से देखो. Yes, the tricks to solve problem. Don't do's and very important problems, very important problems. ये भी आपके नोट्स में होने चाहिए. इन शॉर्ट, यस, इन शॉर्ट. डेरिवेशंस, वेल, इतना जरूरी नहीं है फॉर नीट एटलीस्ट, बट अगर आप जेई एडवांस या फिर ऐसा कुछ कर रहे होते तो देन आई वुड से यस, डेरिवेशंस आर इंपॉर्टेंट. बट हाँ, मैं ये नहीं बोल रहा हूं डेरिवेशंस are not important. Derivations are not important in your funda book. But if you think that derivation should be there, please keep it, no problem. ठीक है? But as such, derivations you should know, but not necessarily in the funda book. JEE Advanced के लिए strategy अलग होता है, so उसका game अलग ही है. Do not worry about it. Important problems, जैसे मान लो, हाँ, कि अच्छा एक पुली है, एक ब्लॉक है यार, ये हमेशा आता है, ये 8 वुड मशीन, एक ऊपर जा रहा है, एक नीचे जा रहा है, वो प्रॉब्लम होना ही चाहिए. ठीक है, सो दैट यू सी इट अगेन एंड अगेन. एंड लास्ट थिंग, ऑल द मिस्टेक्स इन फिजिक्स दैट यू डू, कॉमन मिस्टेक्स. इट कुड बी मिसरीडिंग, इट कुड बी ओवर एस्टिमेटिंग, अंडर एस्टिमेटिंग, वॉट एवर प्रॉब्लम्स यू डू, तो ये सब आपके नोट्स में होना चाहिए. एंड एवरी टाइम यू अटेम्प्ट अ पेपर और अ प्रॉब्लम एंड यू डू अ मिस्टेक, मार्क इट. अच्छा, दूसरे बार किया, अच्छा, तीसरे बार किया, ओके, चौथे बार किया, अच्छा, पांचवें बार किया, ओ, यू आर डूइंग दिस मिस्टेक मेनी टाइम्स, ओके, यू विल कीप दैट इन माइंड. यस, यू हैव टू कीप दिस इन माइंड. ओके, तो ये सब आपके नोट्स में होना चाहिए. इज दिस क्लियर? इज दिस क्लियर? तो ये सब आपके नोट्स में होना चाहिए गाइज. यस, आई होप दिस इज क्लियर. ओके, आई एम ट्राइंग टू, Pavni, okay, I'm trying to keep it in a mix. Yeah, all these things. So important problems should be there, guys. So important problems, very important problems which are very commonly asked, all these things should be there. Do not do should be there. Tricks of the trade should be there. Mistakes should be there. Now, what kind of tricks am I talking about? Let me give you a simple trick. Yes, let me give you a simple trick. Let me give you a simple trick. Okay? Observe this. Rotation, so difficult, right? So difficult. I'll give you a trick. Shall I give you a trick? Chalo, I'll give you a trick. Dekho. Look at this. Look at this. Look at this problem. Looks so difficult, but not after you attend my session out here. Pulley hai. This is a pulley. Yes, which has mass. And there are 2 masses here and they are going up and down. Now you might be like, sir, I know how to solve this problem. I will write the equations, tension mg and Pulley torque equations. I will solve those three equations and I will write A is equal to alpha r and then I'll get it. Guys, do you really think you have so much time in the exam? Really? You don't have so much time in the exam. So what is the trick? I'll teach you a trick. What is the trick? The trick is called opening up method. What is it called? Opening up method. So what do you do in this method? Open up. But what do you open up? This Pulley mass system. So let's open this up. And when I say opening up method, first think, what are the forces on these blocks? The forces on these blocks are mg and 3mg. mg and 3mg, these are the two forces. Okay, I hope this is clear. Tension bhul jao. Bhul jao. Just like you have to forget exam tension, just forget the tension over here also. Okay, now open it up. Open it up. And it will look something like this. It will look something like this. This m has gone here and this 3m has gone here. Even these forces will go like that. Yes, even these forces will go like that. This will be mg and this will be 3mg. Yes. Now forget the original problem. Now forget that original problem. This is not needed only. What was the mass of the pulley? It was 2m. Okay, I hope you guys understood this. All I have done is opened it up. The mg and the 3mg went here and this pulley of mass 2m is still there. All right. Now, yes, Mini, I'm teaching in English only. I'm teaching in English only. Okay. So understand now what to do. Just forget the tension. Remember, that's what I told you. Take this as a system. Take this as a system and use my formula. What is my magical formula? The acceleration is the larger force minus smaller force divided by masses which are translating plus equivalent mass which is rotating. Yes, this is my formula. If you use it 2-3 times, you will remember it. Larger force minus smaller force upon mass which is translating plus equivalent mass which is rotating. Okay, let's try to use this. So what will be the acceleration? Larger force. Which is the larger force out of these two? mg or 3mg? Obviously 3mg. तो 3mg जो है बड़ा force है. Smaller force कौन सा है? mg. That's it. Upon the masses which are translating. What is the mass which is translating? M and 3m. So m and 3m. So that's it. That is the translating mass. I hope this is clear. Yes, this is applicable for 11th also. Observe this. Now the equivalent mass which is rotating. Which is that equivalent mass which is rotating? Okay. Now this mass is rotating, but do not put, please don't put 2m. No, don't put 2m, guys. You have to put the factor which comes in moment of inertia. Do you remember the moment of inertia formula for a disk? For a disk, what is the moment of inertia formula? Think about it. Think about it. mr square by 2, correct? It's mr square by 2. So it will be 2m r square by 2. ये 2 आता है ना? This 2 comes, right? This 2 comes, right? Half. Remember mr square by 2, half that. Yes. So just multiply, basically because you get a factor of half something r square, just use that half over here. That's it. The job is done. That's it. Just the job is done. The equivalent mass is the mass which is rotating into the factor which comes in the moment of inertia formula. Job is done. So you can cancel this out. So what is 3mg minus mg? It is nothing but 2mg. And what is m plus 3m? Well, that is 4m. And what is 2m into half? Well, that is m plus 3m plus m. Socho, it will be 5m. And m goes, and the answer is 2g by 5. 2g by 5. 2g by 5. That's it. I hope this is clear. Is this clear? Translatory mass, Harshini, are those masses which are moving. Only moving. They are not rotating. So which are the masses which are moving? M and 3m. Which is the mass which is rotating? 2m. But don't take 2m. Multiply it with a factor which comes in the formula of moment of inertia. Are you guys amazed? Are you guys amazed? Yes or no? Yes. Very good, very good. Rotating mass is the mass which is rotating here. So the pulley is rotating. So that's the rotating mass. Very good, very good. Amazing. So, how to make notes understood? Tricks, tips. These kind of tips and tricks I give. Just say, fat say you will get the answer. Okay, why to make notes? Now, I'll tell you. You have just passed out from 10th standard just 1 or 2 years back. So, let's say when you were studying history in 10th standard, all right? And the question was, when did Bhagat Singh die? Or when was he hanged and stuff like that. तो सबसे पहले आपके दिमाग के अंदर क्या आता है? You will be recollecting, yes, you will be recollecting Bhagat Singh ka picture in that history textbook. In that there will be a paragraph on Bhagat Singh. Somewhere it will be written, oh, Bhagat Singh was hanged on so and so date for so and so reason. है ना? है ना? So what is happening? Mental picture आ रहा है. Oh, you are recollecting. अच्छा, पेज के उस तरफ था. Okay, भगत सिंह का फोटो था. इधर लिखा था भगत सिंह died on this date. So same thing should happen here. Now remember this very important rule to remember formulas. What is that rule? You should always study the same formulas, concepts, whatever I gave you in the previous slide. Okay? Everything from the same notes again and again and again. At least 100 times. At least बोल रहा हूं मैं. At least. You should have seen it at least 100-200 times before the NEET examination. Now what happens when you study from the same book? Immediately, let's say some formula is asked, magnetic field due to a current carrying coil. You will immediately recollect, अच्छा मेरे notes में इधर था वो, ऐसा वो diagram था, and this was the formula. That's how it is. That's how it is. Okay? So, what happens if you do not make your notes? Well, you would have studied H.C. Verma, S.L. Arora, D.C. Pandey, टीचर की नोट्स, ये मॉड्यूल वो मॉड्यूल, आपके दिमाग में कुछ एक पिक्चर ही नहीं बन पाएगा. पिक्चर ही नहीं बन पाएगा यार कि कहां से याद करूं मैं. तो इसीलिए सेम बुक ऑलवेज again and again and again, so that after you make your notes, you don't have to go back to H.C. Verma, S.L. Arora, that module, this module. You don't have to, because you already made those notes. I hope this is clear. Very good. Now, are you guys ready for the magical trick? Magical trick. Magical trick के लिए ready हो कि नहीं? Josh is high. Josh is high. Yes, self notes are the best. I agree. यार कोई बोल रहा है हिंदी बोलो, कोई बोल रहा है इंग्लिश. आई एम कीपिंग अ मिक्स, बट आई विल कीप मोर ऑफ इंग्लिश. ऑल राइट, ऑल राइट. सो गाइज, गेट रेडी. आर यू एक्साइटेड? यस और नो बोलो. यस, रेडी टू लर्न. सर बताओ, वो एक ऐसा मैजिकल ट्रिक बताओ, ऐसा खतरनाक ट्रिक बताओ कि मतलब हमारा जिंदगी पलट जाए. चलो देखते हैं. व्हाट इज दैट मैजिक? लेट्स सी व्हाट्स दैट मैजिक. This is the magic. I'll be like, what the hell? इसमें तो कुछ भी नहीं है. ये क्या है? ये कौन सा ट्रिक है? Hold on. Okay, अब ध्यान से सुनो. Okay, because you will not get the PDF of this, but you can always rewind the session and you can always see whatever I have written. Observe carefully. Now, every translating term has an equivalent rotating or circular term. And I'm going to extend this so much that you are going to love this. Observe. In translation, X represents position. X represents position. In rotation, the position is called as angular position, and it is represented by symbol theta. Here the unit is radian, whereas in translation it is meters. Okay, then you have displacement. Symbol is S, and it is delta x. Again, unit is meters. Okay, but here in rotation you have angular displacement. you have angular displacement. There is no special symbol like here, but it is just delta theta, and that is radians. That is radians. Okay. Next, observe. It's going to get interesting. शुरुआत में लग रहा होगा हाँ पता है. Hold on. It's going to get very interesting. Next, you have velocity. Velocity. Well, there are two types. One is average. Average is delta x by delta t. You have instantaneous, which is dx by dt. Same way, you have angular velocity. Okay, symbol is omega, but average will be delta theta by delta t, and instantaneous will be just d theta by dt. When you talk about velocity, you always use the position time graph and you draw a tangent. You always use a position time graph and you draw basically a tangent, and ये tangent का slope देखते हो आप लोग, right? So it's always the slope of x versus time graph. But in rotation, instead of x versus t, you draw theta versus time graph, and then you draw the tangent, and then you measure the slope of theta versus time graph. You measure the slope of theta versus time graph instead of x versus time graph. Is this clear? Is this clear? Poonam, I'm not ma'am, I'm sir. Okay. All right? All right? Okay. Great, great, great. Now, let's continue this. I'm going to erase. You can always take a screenshot of this slide. Don't worry. And now, again, going back. Oh, 1 second. Okay. Again, this is translation and this is rotation. Okay. Quickly. In translation, you have acceleration. Acceleration average is delta v by delta t, but instantaneous is dv by dt. Here you have angular acceleration and alpha is the symbol. The average value is change in angular velocity upon time, but instantaneous value is d omega by dt. Keep this in mind. And in translation, you always look at velocity time graph and then you take the slope of velocity time for measuring acceleration. But in rotational motion, you draw the graph of angular velocity versus time, and you draw the tangent, and you measure the slope of omega versus time. I hope this is clear. I hope this is clear. Very good. Very good. Now, take a screenshot of this before I go ahead. Take a screenshot. Okay. Now, next, again, we are back to translation on the left side. This is translation and this is rotation. Observe this. It's going to get more interesting now. Like you have V is U plus AT, S is UT plus half AT square, V square is U square plus 2AS, and displacement in nth second is U plus A by 2 into 2n minus 1. Usi tarah in rotation, instead of final velocity, you have final angular velocity is initial angular velocity plus angular acceleration into time. Here you have angular displacement is equal to initial angular velocity into time plus half alpha t square. Keep it flowing. You are going to see more than 50% formulas within no time. Mark my words. Then this will be final angular velocity square is equal to initial angular velocity square plus 2 alpha delta theta. S is displacement. Last, displacement in the nth second is, instead of u, you will have initial angular velocity, and here you will have, instead of a, you will have alpha by 2 into 2n minus 1. And all these are valid when acceleration is constant. And this is valid when alpha is constant. Okay, keep this in mind. Take a screenshot. Take a screenshot. All right. I'm erasing this. Okay, next. Again, translation. Here you have rotation. Here if you have V, and here if you have equivalent omega, please remember V is omega into R. Correct? In fact, so much that the length of an arc and the angle subtended are also related by the same relationship, just multiplied by the same term, multiplied by the same term, R. R is the radius. Next, tangential acceleration is again the same thing. It is nothing but alpha into R. Alpha into R. I hope you can see that. Please take, Atir, Aslam, please take screenshots. Yes. Please take screenshots. Yes. Very good, very good. Next. Again, translation. Here you have rotation. Here in translation, mass. Pay attention now. It's going to get very interesting. The equivalent of mass in rotation is moment of inertia. This is just called mass or inertia. Here it is called as moment of inertia. That's one difference. Next, you have force, which is F. Here you have torque. That is moment of force. Force, moment of force. Inertia, moment of inertia. Next, momentum. P. Here you have moment of momentum, which is also called angular momentum. And the symbol is L. The symbol is L. Guess what? Torque is nothing but R cross F. And guess what? Angular momentum is R cross P. Guess what? Yes, I hope you can see that. I hope you can see that. Very good. Vector notation. And guess what? Momentum was mass into velocity, right? Momentum is mass into velocity. Guess what? Angular momentum is angular mass into angular velocity. It was there in the previous slide. I omega. I hope this is very clear. I hope this is very clear. Are you guys excited? Are you guys seeing so many things? Very good. Hold on. It's not done. We are hardly scratching the surface. Wait. Next. Again. Okay, just one sec. Okay. Again, here, translation. Here, rotation. In translation, think about it. If net force is 0, then momentum is conserved. In rotation, if net torque is 0, then angular momentum is conserved. Angular momentum is conserved. All right. Next, torque acting on a body, force acting on a body is mass into acceleration. The net force gives mass into acceleration. Here, net torque gives moment of inertia into angular acceleration. That's what it gives us. That's what it gives us. Interesting. Interesting. Next, you'll be like, sir, oh my God, is there more? Yes, guys, I have barely done any percentage. Observe now. Okay. In a spring block system, time period is 2 pi under root m by k. Correct? Similarly, in rotation, if you have a rod connected to a disc-like object, if this is the torsional constant and if this is the moment of inertia of that body, the time period, so when you rotate it, it goes back and forth like that, angular wise. That time period is 2 pi under root. Instead of m, you have moment of inertia. Instead of spring constant, you have, this is torsional constant that will be given to you in the exam. Torsional constant. I hope this is clear. I hope this is clear. All right? Don't get scared. I'm giving you comparison charts. Next, just like in normal SHM, the equation is A sine omega t. In angular SHM, it is theta is equal to theta naught sine omega t. Instead of amplitude, you have angular amplitude. Instead of position, you have angular position. Omega is the same. You can see the relationship. Next, you'll be like, what more? Yes, there is something more. Just like in a SHM, which linearly oscillates, the force is inversely proportional, is opposite and proportional to x. Same way, in angular SHM, somehow show the torque is inversely proportional to the angular displacement. I hope this is clear. Very good. Let that tsunami keep coming. Very good, Pritin, Rishi, Mini, very good. Kya baat hai? Atir, Aditya, Shifa. Amazing, amazing, amazing. Okay, now you'll be like, और कुछ बताओ. कोई बात नहीं, और भी बताता हूं. This is mechanics. Here you have electromagnetism. Like, what the hell? How did mechanics and electromagnetism come? I thought gravity and electromagnetism, fine, I can relate, but mechanics and electromagnetism? What the hell? Okay, observe. Pay attention. Mass in mechanics is equivalent to L. This is inductance. Yes. It's the electrical inertia. Electrical inertia of a circuit is called inductance. This is inertia of motion. किसी का L ज़्यादा है. Somebody has large inductance. It has large electrical inertia. Next, observe. Spring constant. This is spring constant. In electromagnetism, it is 1 by C. That C is capacitance. Do not believe me? It's okay. I'll make you believe it. See, you have a spring block system. When it oscillates, what's the time period? 2 pi under root m by k. Let's go to electromagnetism. Instead of mass, you have inductor and you have capacitor. LC oscillation. What's the time period? It's the same thing. Believe me. Instead of M, what will you put? L. Instead of K, what will you put? 1 by C. Instead of K, 1 by C. वो C ऊपर चला जाएगा. I hope this is clear. I hope this is clear. Amazing, amazing. That's not all. That's not all. Observe now. Observe what I'm going to do. Well, in physics, you have something called as the damping constant. Damping constant, BV. Damping पढ़ा होगा आप लोगों ने, जैसे viscosity में 6 pi eta RV. Force is proportional to velocity but opposite to it. Okay? Similarly, you have things over here. And let me tell you how. In mechanics, if it is X, in electromagnetism, it is charge. Yes. In mechanics, if it is velocity, it is dq by dt, which is nothing but current, just like velocity was dx by dt. In mechanics, if acceleration is dv by dt, then in electromagnetism, it is di by dt. Yes, and just like inertial force, which is the pseudo force, is always minus ma, same way in electromagnetism, yes, in electromagnetism, the inertial force का equivalent is EMF, electromotive force, EMF, force का equivalent is minus, instead of mass, क्या आएगा बोलो? Inductance. Instead of acceleration, क्या आएगा बोलो? di by dt. देख लो यार, देख लो. Observe this. Observe this. Observe this. I hope you can see that. L di by dt, that's the EMF across an inductor. Amazing. Acha, this is nothing. Wait a minute. What is the energy in spring? What is the energy stored in a spring? Half k x square. What is the equivalent of spring? It is energy in capacitor. So what will it be? Half. Instead of k, what will you put? 1 by c. Instead of x, what will you put? Charge. So it is basically q square by 2c. Amazing. Look at the equivalence. Not just that. Energy in motion, that is kinetic energy. How much is it? Half mv square. So energy of a moving mass. In electromagnetism, it is energy of not the mass. What is the equivalent of mass? Inductance. Energy of inductance or inductor basically. How much will it be? Half. What is equivalent of mass? L. What is equivalent of velocity? Current. Khatam. Ho gaya. Half Li square, half mv square. So simple. I hope this is clear. I hope this is clear. Very good. Very good. So, understand mechanics mein force is equivalent to. So if this is mechanics, in electromagnetism, if it's force, it's EMF. Just like you have drag force is equal to B into V. This B is damping constant. Here, instead of V, you put current. Instead of B, damping, you will get resistance, and then this will be the force, or basically the EMF across the resistor is IR. That's Ohm's law. That's Ohm's law. So damping constant is equivalent of resistance. Understand that. That's how you can remember it. Isn't it interesting? Look at that. Very good. Very good. Now, let me show you more. Let me show you more. How you can relate electricity and magnetism. Yes, electricity and magnetism. For example, For example, I want to talk about a dipole, plus and minus charge, separated by some distance. The electric dipole moment P is given by charge into length. In magnets, you have the north pole and the south pole. This is plus m, this is minus m. You have the magnetic dipole moment, and that is given by the magnetic charge into the magnetic length. Then you have the torque on a dipole. What is the torque on a dipole? P cross electric field. The torque on a magnet is magnetic dipole moment, which is m, cross basically the magnetic field. Yes. Similarly, you have potential energy is minus P dot E for electricity. In magnetism, the potential energy of a dipole kept in somebody else's magnetic field is given by minus m dot B. Minus m dot B. Yes. Then, not just that. Not just that. Look at that. Electrical energy density. Yes, energy stored per unit volume is given by half epsilon naught E square. In magnetism, magnetic energy density is given by, जहां पर भी एप्सिलॉन आया in magnetism it will become ulta, नीचे आ जाएगा mu naught will come exactly the opposite way, so mu naught will come down, and instead of electric field you will have magnetic field. That's all. That's the difference. Okay, I'll give you something more interesting. You have a charged plate. The charge density is sigma. The electric field will come both ways. That electric field is given by sigma by 2 epsilon naught. Right? That's the electric field. Now, you have a sheet which has many wires carrying current. The magnetic field which is around it, the magnetic field which is around it is given by a very similar formula. Instead of sigma, you have lambda, which is linear current density. See, always magnetism and electricity mein, wherever there is area, you'll have length. If you have length, you'll have area. If you have epsilon naught, here you have mu naught. If you have epsilon naught here, here you have mu naught. It's always 36 ka aakda. 36 ka aakda. Very good. So, instead of area density, you have linear density. 2 is there here and epsilon is below. So, take it up. So, that's the answer for magnetic field. That's the answer for magnetic field. Amazing, right? Amazing, right? Hold on. I'm erasing this. You can take a screenshot. More. How many times you get confused in Ampere's law and Gauss's law? In electricity, cyclic integral E dot dA is Q in by epsilon naught. That is Gauss law. Correct? What did I say? Electricity and magnetism का 36 का आंकड़ा है. Wherever there is area, there is length. So in magnetism, you have, instead of area, you have length. And here you have current inside by epsilon naught. Oh, sorry, my bad. Epsilon naught will not be there, so it will be mu naught. Since epsilon naught is below, mu naught will come on the top. Okay, next. In electricity, if I take cyclic integral dot dl, yes, if this is static electric field, then the answer is always 0. In magnetism also it works the same way. Cyclic integral b dot, instead of length you will have area, it is dot dA, this will be 0. दोनों पढ़ाता हूं अशोक. Yes, this is the formula. All right, very good. One more thing. This is electricity, this is magnetism. In electricity, sorry, 1 second, this was mechanics and this was electromagnetism. In electromagnetism, the EMF induced, which is E, magnitude wise, is given by d phi by dt. What is phi? Flux. And what is it? Magnetic field into area, right? That's the formula. EMI, electromagnetic induction. EMF developed is derivative of rate of change of, that magnetic flux. Now, believe me, think about it. In mechanics, the force is dP by dt. This P is momentum, right? This P is momentum. And remember, momentum was mass into velocity. In magnetism, equivalent of momentum is flux. Yes, this flux. And flux is, instead of mass, you have inductance, and instead of velocity, you have current. And isn't this also a relationship which you have learned? Isn't this also, yes, Naomi, I remember you from VNQs. Isn't this also an important relationship? Very good, very good. Look at the similarities. I hope this is your reaction right now. I hope this is your reaction right now. And believe me, this is just some of them. There are so many relationships. Yes, इतने ज़्यादा रिश्ते हैं, बैठूंगा तो मज़ा आ जाएगा मतलब. Yes, this is for 11th also. तो guys, मैं कहाँ से आया हूँ, मेरा नाम क्या है, कुछ लोग पूछ रहे थे. Let me go back. Okay, this is my name. I also teach in VNQs. VNQs जो JEE English channel है. Yes, the JEE English channel, that's where I teach for all the JEE aspirants. You are welcome anytime. Knowledge बढ़ रहा है. Like Amir Khan says in that movie of Three Idiots, जहां गंगा बह रही है ज्ञान की, वहां पर बैठ जाओ, फर्क नहीं पड़ता, फर्क नहीं पड़ना, कहीं पर भी बैठ जाओ, जहां से भी ज्ञान बढ़ रहा है. So that's my Instagram ID, Shreyas_Vedantu. I keep posting regularly, I keep updating, I keep interacting with students, so you can follow me there too. Yes, you can follow me at Shreyas_Vedantu and at VNQs. All right, I hope you had an amazing session. And if you would like to enroll into any of the courses, this is my coupon code SHHPRO. You can use it for enrolling into any course and you will get 20% off. That's an amazing discount considering the festival season is on, and 20% is a big number, believe me. Usually the percentage is 5%. All right, and this is the Telegram group of our VNQs channel. A lot of things I'm giving you, I know, because I've come here like a guest lecture. So please bear with me, because I want to tell about my channel as well. All right. So I hope you guys have enjoyed. Please let me know by giving all those likes and comments. I'm going to read all your comments and those likes that you're going to give. And if you're a new user to this channel, VBiotonic, you have to subscribe, guys. If you want to see me more, you have to like and subscribe, or else I won't come. Come on, guys. Yes. I hope you enjoyed this. I hope you enjoyed. Yes, Sarla, I took your name. क्या बात है. Yes, yes, I'll keep coming. Thank you guys for your immense love. Well, Manuel, तुम्हारा भी नाम ले लिया. चलो, भावास तुम्हारा भी नाम ले लिया. नेक्स्ट क्लास कब होगा जल्दी बताएंगे. All right, I hope आप सब लोगों को मजा आया. I hope you guys have learnt a lot. Do not get scared by physics. Physics डरावना नहीं है. बस आप पढ़े नहीं हो या फिर आप बराबर किताब से नहीं पढ़े हो. Don't worry, I will teach you. I am there to guide you. मैं हूं ना, like I said. All right. चलो ऋषि तुम्हारा भी नाम ले लिया. Thank you प्रीति. Thank you Zeba. Thank you Aditya. Bye guys. So that's it from me today. See you again until next time. And keep following, keep liking. Thank you again Vani ma'am for giving me this wonderful opportunity to be here with the most amazing crowd that I have ever seen. What an amazing crowd. I'm really thrilled. Thank you guys. Bye. Signing off. This was Shreyas here, your master teacher for physics. And I was going live from the studios at Bangalore. Bye.